So in example number 2, what we will do now is to flip the angle and see how it would happen in different quadrants. In example number 2, starting with angle, that is 70 degree. This angle is 70 degree. This is 70. If I am to reflect this angle in the y-axis, here is my angle open to the right side. If this angle points to the right hand side in quadrant number 1 and you try to flip it in the y-axis, when you try to flip it over, you are going to see a new angle. This terminal arm will now go here. Well, obviously this angle wouldn't be 70 degrees. We had 70 degree here. When you reflect this angle in the y-axis, that would also be 70, isn't it? But if I want to measure this angle starting from 0 degree, if I want to measure this angle starting from this point, how big is this angle? 110. How did you get it? 90 plus 20. But we try not to use angle on the y-axis. Instead, we want to use the x-axis and the terminal arm to figure out our angle. So in this case, the one that goes from 0 to the red terminal arm would involve angles that is 70 degrees less than 180. So this is how we measure our angle in trigonometry, in pre-calculus. We don't use 90 degrees to find our angle. We don't consider this angle as 90 plus 20. Instead, we want to consider this angle as 180 minus 70 degrees.
But we'll get the same answer.
You will get the same answer at the end. If you are doing this kind of math in physics, you probably will use the vertical line to measure the y component.
But we always want to use it.
Yeah, in math, we use the x-axis instead. Now, at the same time, if I want to reflect this angle here in the x-axis, this terminal arm will now go this way. Similar to the one in quadrant number 1, you are still going to see a reference angle of 70 degrees. But when you want to measure your angle from 0 to this terminal arm, it wouldn't be 70. How big would it be?
180, 360 minus.
Yeah, 360 minus 70. This will be 360 degrees minus 70. You are not trying to compare this angle with 180 anymore. 180 degrees would involve angles in quadrant number 2 or quadrant number 3. But now we have our terminal arm in quadrant number 4, which will have its angle closer to 360. And you are going to compare your terminal arm with 360 degrees using your reference angle here. So 360 minus 70 degrees, that will give us 290 degrees. And this angle happens in quadrant number 4. which makes sense because any angle in quadrant number 4 will go between 270 to 360. And now, if I want to reflect this angle in the x-axis first and then the y-axis, my angle will now happen in this quadrant. I'm still going to see 70 degree here using its reference angle. But if I want to measure this angle from 0 degree, and as you measure your angle going all the way to this point, how big would it be? Would it be bigger than 180? Yeah, it definitely goes beyond 180, and it goes beyond 180 degree by that much. We add them together.
So
Yes.
quadrant 3 is the only one that we add.
Correct. Quadrant number 3 is the only quadrant that will add your angle by this. Quadrant number 2, you subtract your reference angle from 180. Quadrant number 4, you subtract your reference angle from 360. In quadrant number 3, you add your angles. You add your reference angle to 180, and it happens in quadrant number 3. When you are describing your angle, measuring from 0 degree up to its terminal arm, we call this angle in standard position. Angle in standard position will always have your angle measured from 0 degree going counterclockwise.